And welcome back. In this video, we're going to solve this question regarding non-homogeneous Poisson process. So what is a non-homogeneous Poisson process? It's a process where customers or the rate of arrival is changing with time. So it's a function of t which is time. And in this question, we have a hot dog stand that opens from 8 a.m. to 5 p.m. And customers arrive with different rates in different time intervals. So, for example, from 8 a.m. to 11 a.m. in the first 3 hours, customer started arriving with rate 5 per hour at 8 a.m. And with a steady rate, it increases to reach 20 customers per hour at 11 a.m. And the question goes like this. So let's summarize the distribution. So the summary of the question can be shown as follows. From 8 to 11, we have a steady increase from 5 to 20. From 11 to 1 p.m., the rate is constant at 20. And from 1 p.m. to 5 p.m., it is decreasing, steadily decreasing from 20 to 12. So how can we write this as a proper distribution, Poisson distribution? Um, we can do the following. Lambda will be written in terms of t, right? So how to find it for each interval? Let's see. So we have the first interval from 8 to 11. In this interval, we have 3 hours. And in these 3 hours, it increased from 5 to 20. So it increased 15 units over lambda. So on average, it's increasing 5 units per hour. The next time interval, it's already constant, so it's fine. And for the third one, we have 4 hours from 13 to 17. That's 4 hours with a decrease of 8 units. So that's 2 units per hour. Per hour, yes. So how can we write this in a proper form as a function of t? Let's consider 8 to be t is equal to 0. We start at 8, so t at this point is equal to 0. And we're starting from 5. So as we are increasing at 5 units per hour, we can write this as 5, our starting point, plus 5t. This is for t from 0 to 3, right? So 8 at 8t is 0, at 9t is 1, at 10t is 2, and at 11t is 3. And let's test this for t is equal 3. 5 plus 5 times 3, this is going to be 15. 5 plus 15 is equal to 20. So we have our value here. Okay, perfect. So for the second thing, for the second time interval, it's 20. It's constant, so we directly write 20. 40 from 3 to 5. Perfect. Now, for the third interval, how can we write it? Let's just write here, t is from 5 to 9, because we have 4 hours. How can we write this here? So we want it at t is equal to 5. At t equals 5, we want it to be 20. So what is the constant? We know that the rate is 2t, so It's something minus 2t because it's decreasing. So something, let's call it x, minus 2t is equal to 20. And t at this point we said it's 5. So x is equal to 20 plus 10, which is 30. 30. So this will be 30 minus 2t. And to test it, let's take when t is 9. So 2, 9, and this is 30. So 30 minus 18, that's 12. And here it is, our value. So let me quickly clean all of this. So basically, this was the first part of the question. Let's call it A. That's cool. Let's now do part B. What is part B? Part B asks us what is the probability that no customers arrive between 8:30 and 9:30 on Monday morning. Okay, so here our K is equal to 0 and our lambda is a Poisson, um is non-homogeneous, sorry. So if we consider 8 is equal to 0, so it's from half to 1.5. So it's m 1.5 minus m half. So let's find lambda first, which is actually the question for the third part. What is the expected number of arrivals in this period? So let's first find lambda. And to find lambda, we should do the following. The integration from half to 3 over 2 of the function that includes this period from 8:30 to 9:30. So 8:30 to 9:30 is actually here. So we have 5 plus 5t dt. So let's take the integration of this. This is 5t plus 5 over 2 t squared. And this is taken from 1/2 to 3/2. After taking all the calculations here, we can find the result to be 10. So, in this period, from 8:30 to 9:30, our expected value is 10, which is actually the answer for C. So let's continue B right now. If we have, this is our lambda now. Again, we say K is 0, which is the probability that there is no customer arriving at this period, and our lambda is 10. What is the probability? The probability can be found, let's call it the probability of x. I hope we didn't use x before. Yes, x is the event of no customers arriving at this period, and the formula is lambda to the power of k, then k factorial, then e to the power of minus lambda. So since k is 0, k factorial is 0, lambda to the power of k is 1, so we are just having this. Sorry, this is 1, my bad. Yeah, dividing by 0 will give us infinity. So this is 1, and that's 1. So we're just left with e to the power of minus lambda, which is e to the power of minus 10. And if we calculate that, e to the power of minus 10, that's 0.0000045. So it's better to just write it as e to the power of minus 10. Yeah, so and for part C, as we mentioned, it's basically asking for the expected value, and we found it while solving B to be 10. And that was all for this question. It's a short question. I hope it was helpful. And good luck. See you in the next videos.